Good evening, friends. Today we are going to discuss eccentricity method of ellipse. So last video we discussed about eccentricity method of parabola. So similar as same as previous method, this method also. So here also I will give clear information. So those who missed eccentricity of parabola, you can see the last video. Okay. So now start our topic. So here the question is, in this eccentricity method, we will give the eccentricity. Suppose assume that eccentricity is equal to 2 by 3 is given. 2 by 3 is given. And distance from directrix to focus is given 50 mm. Okay, 50 mm. And tangent and normal at 30 mm. Tangent and normal at 30 mm. So the question is, draw the hyperbola or draw the curve of eccentricity is 2 by 3. Of eccentricity is 2 by 3. And the distance between directrix to focus is 50 mm. And draw a tangent and normal at 30 mm to the curve. So this is the question. So in this question, same thing as previous method, what we have to do means, first draw the vertical line. Draw the vertical line. So this vertical line, we know that it is directrix line. It is directrix line. So directrix line. And draw the horizontal line. Draw the horizontal line. So this line is called axis line. We call it is axis line. Axis line. Axis line. And the starting point which is intersects both this x-axis and y-axis, or vertical axis and horizontal axis, this point is A. We call it is, this point is A. And this point is A. And directrix to focus distance is given 50 mm. So mark that point. So that point name is F. It is focus. So directrix to focus AF is 50 mm is given. And here the main thing is eccentricity. So last video also I told that the vertex point is very important here. Depends upon the vertex point movement, the curve changes, either it is parabola, ellipse or hyperbola. The eccentricity decides. So here eccentricity means, last class I told that the eccentricity formula is, eccentricity is equal to focus to vertex FV divided by VA. Focus to vertex divided by VA. Vertex to focus. So vertex is always between focus and directrix point. So suppose here what is given, FV by VA, what is given? It is 2 by 3 is given. 2 by 3. So what you have to do? Just to add these two values. Add these two values. Numerator and denominator. Both the values you add it. So 2 plus 3 is equal to 5. 2 plus 3 is equal to 5. So whatever the length is there, A to F, 50 mm is given. Divide into equal number of 5 parts. Either you can divide directly or indirectly method. Suppose 1, 2, 3, 4, 5. So 5 equal parts you divide it and give the numbering for this reverse order. 1, 2, 3, 4 and this A point is 5. Okay. So after dividing this, what you have to do? Numerator value divided by denominator. What is the numerator value here? 2. So 1, 2. Where the 2 number you are getting, mark that point. Mark that point and give that point is vertex point. Okay. So 2 portions divided by 3 portions. So FV divided by VA. So 2 portions divided by 3 portions. So 2 by 3. So this is 2 by 3. So vertex is the second point. So now draw the vertical line through the vertex point, and this line should be parallel to directrix line. So as it is same method as previous parabola. And then what you have to do? Keep V is the center, up to F is the radius. Draw a semicircle. Draw a semicircle. So it touches 2 points on this line. Okay. Now join this A to F, this point, and extend the line, and A to this point and extend the line. So these two inclination lines are limit of the arc. Then what you have to do? So vertex point, always curve starts from vertex point. So from here take number of points, either equal lengths or unequal lengths. So point 1, 2, 3, 4, 5, 6, 7, 8 like that you take up to the where you are going to get full ellipse. Full ellipse. So first point, suppose first point is there, draw the vertical line. It should be parallel to vertical axis line or directrix line, and from the second line draw the vertical line, from third is all the parallel lines, and fourth line, fifth line, sixth line, like that you go for up to the end of the ellipse. So all the vertical lines you project all the vertical lines and give the numbering. Suppose this is the first line and here is 1 dash, this is 2 dash, 3 dash, 4 dash, 5 dash, 6 dash and 7 dash, like that you go for. And below side also you give same numbering, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, like that up to end of the curve. Now take the radius. 1 to 1 dash is the radius, 1 to 1 dash is the radius, and F is the center. Always F is the center. F means focus. Focus is the center, and cut the arc. Cut the arc. Suppose this 1 to 1 dash is the radius. This point is 1. Up to this is 1 dash. So 1 to 1 dash is the radius. F is the center, and cut the first line. You will get somewhere. Both the sides you can cut. In the same manner, 2 to 2 dash is the radius. F is the center, and cut the second line. 3 to 3 dash is the radius. F is the center, cut the third line. 4 to 4 dash is the radius. F is the center, cut the fourth line. Fifth line, sixth line, seventh line, eighth line, ninth line, like that. If you go, you will get the ellipse. If you join all the points from the vertex point, you will get the elliptical shape or ellipse you will get. Okay, this is the ellipse. And for tangent and normal, what you have to do? It is given 30 mm to the curve. So from the directrix point, take 30 mm to the curve, mark the point and give the point name is M. So this is 30 mm. So this point name is M. So join this M point to the focus by straight line, and draw a perpendicular line to this. So it touches to the directrix point at this point. Now join this point and this M point and extend the line. This line is called tangent, and perpendicular to this line is called from the M point. So this is normal. So normal is always perpendicular to the tangent. So here the ellipse, tangent and normal, these 3 points are very, very important. So this is curve is one point, and tangent is another point, and normal is another point. These three is thick, and remaining all the figures are thin. Okay, now next one is eccentricity method of hyperbola. This is also same similar method. The only thing is fix the vertex point is different. Okay, so listen carefully. Here the question is the given curve, or draw the curve of eccentricity is 3/2. So AF is equal to, that is directrix to focus is given 50 mm, and draw a tangent and normal at 30 mm. Okay, so 2/3 means it is greater than 1. Greater than 1 means is this hyperbola. Ellipse means less than 1, parabola means equal to 1. So here also same method. So first draw the vertical line. It is directrix line, and draw the horizontal line, it is axis line, and starting point is A, we know already, it is directrix point. So A to F is given 50 mm, so I am marking here F. So this is given 50 mm, and now eccentricity is 3/2. So last class I told that eccentricity is equal to, so vertex point is always between these 2 points. So between these 2 points, so FV divided by VA. So FV divided by VA. So how much it is given? It is 3/2. So numerical value is 3 and 2 divided by, denominator is 2. So 3 plus 2, so 3 plus 2 is equal to 5. So we have to go for 5 equal number of parts. So whatever the length is given, AF divided into equal number of 5 parts. So 1, 2, 3, 4, 5. So give the number in reverse order, 1, 2, 3, 4 and 5. Now, so numerator is so from the right side, take the 2 values, 3 values, why because numerator is 3. So 3 portions divided by 2 portions. So third portion is vertex point. Third portion is vertex point. Third point is vertex point. So from the third point, draw a vertical line, and that vertical line should be parallel to directrix line. And now V is the center, up to F is the radius. Draw a semicircle. Draw a semicircle. So mark the touching point and join A to this point and extend the line. Now A to this point and extend the line. So this is the limit of the arc. Once again the procedure is same. So take number of points from the V. 1, 2, 3, 4, 5, 6, 7, 8. Okay, as your wish. 7 to 10 points you can take any number of points in the examination. So suppose give the numbering here 1, 2, 3, 4, 5, 6, 7 like that. So from the all the points draw vertical lines or parallel lines through those points. So suppose this point is 1, so cut here 1 dash, 2 is there, this is 2 dash, 3 is there, it is 3 dash. In the same manner mark downside also 1 dash, 2 dash and 3 dash, 4 dash, 5 dash, 6 dash, like that you go for number of points. So once again 1 to 1 dash is the radius, 1 to 1 dash is the radius, F is the center, so this point is F. So F is the center, and cut the first line, cut the first point, both sides. In the same manner 2 to 2 dash is the radius, F is the center, cut the second point. 3 to 3 dash is the radius, F is the center, cut the third point. 4 to 4 dash is the radius, F is the center. So whatever it may be, the points will come. Always you come, the focus is the center point. Now join all the points through this vertex point. You will get a hyperbolic curve. Okay, this is the hyperbolic curve. Now tangent and normal from this directrix point parallel to this horizontal line. Mark the, so see the length. Suppose this is you are getting 30 mm here. Okay, so give the point name is M. Join this M point and focus by a straight line and draw a perpendicular line to this, extend up to directrix line. Now join this directrix point and M point by a straight line and extend the line. Okay. Now perpendicular to this line through the M is equal to normal, and this line is called tangent, and this is hyperbolic arc. Okay. So these eccentricity method, parabola, ellipse, hyperbola, these three are same. Only difference is only eccentricity and vertex point fixing. Okay. Now from the in examination, from these three methods, definitely one question he will ask. So these two videos, these are very very important. So the method and next video, individual methods of parabola, different other methods of parabola is there. So those are also very important. So we'll meet in the next video. Okay. So please share and subscribe and encourage your friends to see the videos. Okay. Thank you for your support.